Okay, so have you executed this program? Sorry. Okay, this was executed. Okay, then we'll do this. So you'll get all the values in serially because we have used only one block and n threads. You can change the value here. There's no need, but I'm giving n blocks. Love random values. No, it's a somewhat serial. 5 blocks and threads. Okay. So actually, what happens here is there is some problem with that. I am giving a very low amount of threads. That's the reason. Okay. Still got the answer. Okay, go to the next one. So we'll see how the already you know that in C program we are having some global variables. So what happens while using those global variables? Okay, so I'll paste this particular programs on chat box. Simply execute and see what happens. So here we are having only the message. So in here in kernel program we don't have any operations. Okay, in main program just we are printing this message. The next one, the print message is available here, and also here it uses the device synchronize. And the one more version is also available. So it is used with the help of hash define message. I have pasted all the 3 versions. You see what happens in each and every one. I have exceeded the last one. Let's see. Go to the previous one. has given the same name. Problem. Okay. So let's see the next one. It includes the CUDA device synchronize. Okay. So here we can see some warning message and error message. Uh, so the message is not defined in. Okay. So actually, we have declared one global variable. So after that, we have given CUDA device synchronize like the previous one program, that is for loop program. Okay. So here the printf statement is given here inside the kernel. Okay, printf message, but it is not defined, not at all defined here. Okay, so it won't getting any uh, function. So it gives some error message. So in the next program, so it is here. So the message is defined and hash define message hello world, and we'll see what happens here. So already I have executed. Okay, so it displays hello world 32 times. Okay, one block and 32 threads is used. 32 times it is displayed. If the message is given in preprocessor directive has defined, that will be taken into consideration and it will be executed. Even though it has, if you have used the global variable and the device synchronize, it won't be executed. Okay, like the previous one, if you are not using CUDA device synchronize, the message will be printed. But if you are using device synchronize, it will be printed here. Okay. So, what is the main reason for this particular one? Is uh, so separate memories. The GPU is having separate memory than the CPU. Okay, and both are having separate DRAMs. In CPU, it will be having separate one, and GPU it will be having a separate one. And a variable in CPU memory cannot be accessed directly in a GPU kernel. Okay, CPU can able to access the values inside the GPU, but um, the GPU cannot able to access the CPU memory. That is the problem. Even though it is a global one, even though the message is defined in a global one, it won't be accessed by the GPU kernel. That is the reason. And for this, you have to make copies of the variables. What are the things you have declared there in the CPU? It has to be maintained and declared there in the there for the GPU, and you have to copy all the values of the variables to um, GPU. Okay, so our responsibility is that the programmer's responsibility is this one. Okay, so what are the variables you have declared for CPU? You have to be declare uh, for GPU also, and you have to copy all the contents from CPU to GPU. Okay, so already we have discussed the CUDA program flow. So initially what happens is from the file system, the data is loaded into CPU. Then it is copied from CPU to GPU. Then it will be executed in the GPU kernel, and the result again copied to CPU. Then it will be used on the CPU. Okay, this is the entire program flow. Already we have discussed. Okay, so here for reading the data, either you can use from the file system, also you can read the data using fread, or you can use random values. And for copying, the main thing you have to use is CUDA memcopy. So also CUDA memcopy host to device. These two things are very important. So then you have to launch the kernel using this syntax, and again you have to copy device to, then you can use the results. So any doubt, so any clarification, anything else you want me to tell? This is a block program, already we have executed. So this is a matrix multiplication, we'll see later. So what we have discussed in today's classes, we have seen the usage of threads and blocks. So how the threads are used for parallel execution, how the program in loop program is transferred to a GPU program. Okay, so all those things we have seen. So this is very important for that. So the next class, we can see how we can combine both threads and blocks. Okay, so it's very important. Normally, while for combining threads and blocks, so already you have been gone through the row major index, column major index of matrices. Okay, so either the matrix is stored in memory as column major indexes and column major or row major. So likewise, only it will in GPU also it has stored. So there is some small calculation is there that is done inside the GPU. So using that, you can easily add matrices, um, one-dimensional matrices. Already we have seen one-dimensional matrix. So we can add two-dimensional matrices, and we can multiply one-dimensional matrix. We can multiply two-dimensional matrix. For everything and all, we have to combine both thread IDX and block IDXs. Okay, we'll see that topic in tomorrow. So anything else you want to know? CUDA C++ for one. And so in yesterday's class, I have given two references. So the PPT and the video is already uploaded in the Google Sheet. Okay, so this is a Google Sheet. Okay, everything is uploaded there. So in the lecture two references, you are having two textbooks. You can use those textbooks for CUDA C or C++. And for CUDA Python, I'll tell later. Okay. So I am having some internet materials for CUDA Python. I didn't use any textbook. So in the last class, I will tell. Okay, so how to execute CUDA Python programs, what are the things we needed. So everything we see that time I will tell some books for CUDA Python too. Okay. So any others? Any other? So up to today's sessions, is it clear? So is it clear for you? So then only the thread and the block combination is little difficult to understand. So nothing there is in CUDA program. So you have to remember what you have to copy to GPU. What are the things you have to copy from GPU? That's all. And some small statements. Then only you can easily write CUDA programs. So I'll inform sir to update. Okay. So actually I have updated. That's why it is asking access. So I'll remove that and ask sir to add. Yeah, yeah. So for each and every streaming processor that is it is having SM streaming multiprocessor is having shared memory. That means one block is having one memory that is shared among all the cores in that memory. So all the threads can share that particular memory. Okay. So then thank you again. We'll see you tomorrow's class.